Hello class, today we're going to talk about two-step inequalities. Okay, over the past couple of days we've talked about one steps, so now it's time to move to the next level. But before we do that, let's review what we need to do with one-step inequalities. Well, we know that in order to solve an inequality, we do it exactly like we solved an equation. Okay, our job is still to get this variable by itself, so I need to get anything that's with the variable, I need to move it to the other side. And how do I move anything with addition and subtraction? I add its opposite. So in this first example, we're going to do x plus 7 plus negative 7 is less than or equal to 5 plus negative 7. Okay, then we simplify the line. So I end up with my 7's going away, and we're left with x is less than or equal to negative 2. Okay, now, in order for us to make sure that that is a correct solution, we're going to check it. Okay? So I need to pick a value that is less than negative 2 to plug into our x value at the top. So a value less than negative 2, well, would be negative 3. Okay? Now, one way to kind of help you understand the numbers to choose is to look at the graph. So if I were to look at the graph down here, if I were to do a quick graph and write negative 2, and I need numbers that are less than negative 2, that means I need numbers that are left of negative 2. Okay, so on this one right here, I would put a closed circle because I want to include negative 2, and I need all values to the left of. And the first value that's left of negative 2 is negative 3. So if we were to take negative 3 and plug that into the inequality, negative 3 plus 7 gives me 4. Is 4 less than or equal to 5? And that is a true statement. Okay, so now let's look at multiply. Well, with multiplication, we know that we divide. Okay, so if I take this multiply by 3 and divide by 3, we would end up with m is greater than negative 7. Okay? Now we need to remember that there is one thing that we have to look at when we're dealing with multiply and divide. We have to look at the coefficient. If this coefficient is positive, we solve it just like an equation. But if this coefficient is negative, then we know that we've got to do something to this inequality. We have to flip it. In this particular case, I don't have to worry about it. So I've got m is greater than negative 7. So if I were to come down here, graph our solution set. So I've got an open circle on negative 7, and I want to shade to the right because I need values that are greater than negative 7. And now I need to check this to see if it is correct. So one number that I like to use if it's in the solution set is 0. And in this particular one, 0 is greater than negative 7, so I can plug it in. So 3 times 0 is 0. Is 0 greater than negative 21? Yes, it actually is. 0 is the absence of value, and negative 21 means that you owe somebody $21. Right? Now, the last one-step inequality here is x divided by negative 4 is greater than or equal to 2. Okay, so how do I get rid of a divide by negative 4? I do a multiply by negative 4. So I multiply on the other side by negative 4. Now this is that case that we've got to remember, that if my coefficient, the number with my letter, is negative, my inequality is going to flip. Okay, so instead of x being greater than or equal to negative 8, it's going to be less than or equal to negative 8. Okay, so I come down here, I do a quick graph, put a closed circle on negative 8, and the values that are to the left of negative 8 will make this true. Now, to check this one, I'm going to be a little bit more selective as to what number I choose. I need a value that is less than negative 8, but divisible by 4. Okay, and the first one is negative 12. Okay, so I'm going to do negative 12 divided by negative 4, which we know is going to give me 3. Is 3 greater than or equal to 2? Yes, it is. Right? And that's how we do one steps. So let me ask you a question. Right? Would two-step inequalities be worked the same way as two-step equations? The answer is yes, we do. Okay? So the one thing you do need to remember, though, is that our first step is to get rid of our addition and subtraction. We do that by adding the opposite. Get rid of the multiply divide. Well, we do the opposite, but we need to remember that if our coefficient is negative, we're going to flip the inequality. Okay? So what I'd like for us to do is I just want to work a few two-step inequalities, and then we'll call it a day. So here's our first one. Okay? So a two-step inequality, we know the first thing is move the numbers to the other side. Okay? Because our letters are already together. Okay? So move this 5 to the other side by adding its opposite. So 2x plus 5 is greater than, 2x plus 5 plus negative 5 is greater than 7 plus negative 5. Okay, so our 5's will go away. We're left with 2x is greater than 2. So I divide both sides by 2, and you end up with x is greater than 1. Now, when you're starting an inequality like this, the first thing I really want you looking at is looking at this coefficient. If that coefficient is positive, then we know that we work it just like a regular equation. But if that coefficient happens to be a negative number, I need you to think in your mind, okay, at the end, my inequality is going to flip. In this particular problem, we didn't have to worry about that. Now, if we're going to graph this, we would do a quick graph here of put a 1. Okay, we would put an open circle, and then we would shade to the right because I need values greater than 1. Now, if we wanted to check this, which is always a good idea, to check just to make sure that it's going to be correct, a value greater than 1 is 2. Okay, so 2 times 2 plus 5. Well, 2 times 2 is 4, plus 5 is 9. Is 9 greater than 7? Yes, it is. All right, so let's try another one. Okay, what about this one? Now, some of you, when you look at this kind of a question, you go, oh my goodness, this one's not a very nice one. All right, and the reason why it's not nice is because the x is on the opposite side that we like it to be on. Okay, so you can work this one of two ways. One way is work it exactly the way you see it, because you know eventually you're going to have letters on both sides. Or you could flip this, but you have to be very careful when you flip it. Okay, because with an equation, with an equals, it doesn't really matter which way the inequality or which way that symbol is pointed. Okay, so in this one right here, the way I suggest that you flip it, if you're going to, is you write 3x plus 5, then you write the other side, negative 22, and then we look, which way is this inequality pointing? It's pointing to the 22, so I need to make sure that the other inequality, when I flip it, it's the same way. Okay, now I plan on working it the way I wrote it. Okay, so I just start here at the inequality, and I begin solving. Okay, so I know this 3, I look at this 3, that's the coefficient. Is it positive or negative? It's positive, so I know I'm not going to be flipping the inequality at the end. Not mathematically anyway. So I need to get rid of the 5. So I got 3x plus 5 plus negative 5. So then over here I've got negative 22 plus the negative 5 I added on the other side. So again, the steps are exactly the same as what we've been doing. Okay, so negative 22 and negative 5 make negative 27. And so that is going to be less than or equal to 3x. So now I need to divide both sides by 3. And I end up with negative 27 divided by 3 gives me negative 9 is less than or equal to x. Now at this point, if I wanted to do a graph, I would want to kind of switch it. So I would write the x, I'd write the negative 9, and then I pay attention to which way this inequality is pointing. It's pointing to the negative 9, so I need to make sure it's pointing to the negative 9 when I'm done. So our solution set then is all the x values that are greater than or equal to negative 9. So I come over to the graph, I put a closed circle on negative 9, and I shade to the right because I need values greater than negative 9. Now, to check this, one of the values I could use is 0. So 3 times 0 plus 5. Well, 3 times 0 is 0, plus 5 is 5. Is negative 22 less than or equal to 5? And yes, it is. Okay, so let's work one that's a little different. Let's work one like this. Okay, now, you'll notice in this one that the coefficient, the number that's with our letter, it's negative. So what do I need for you to think about in your mind? This one at the end is going to flip. Okay, so now let's begin. Now, you know the first thing I'm going to do is I'm going to change this subtraction to addition, next number to its opposite. Okay, again, the only reason why we do that is to prevent careless mistakes. Okay, so now I need to move this negative 12 over to be with a positive 12. So negative 8x plus negative 12 plus 12 is less than 12 plus 12. So we end up with negative 8x is less than 24. Okay, so now at this point is when I got to start thinking about the flip. Okay, because now I'm dealing with the coefficient. So to get rid of a multiply by negative 8, I'm going to do a divide by negative 8. And I end up with x, and then 24 divided by negative 8 is negative 3. But my inequality is going to go from a less than to a greater than because my coefficient was negative. Okay, so now we graph it. Okay, I've got a negative 3. It's going to be an open circle on negative 3, and I need values that are greater than negative 3. Okay, so let's see. One of the values that I like is in this solution set, and that is 0. So I'm going to plug that in. Negative 8 times 0 plus negative 12, is that less than positive 12? Well, negative 8 and 0 make 0. 0 plus negative 12 is negative 12. Is negative 12 less than positive 12? And yes, it is, and it works. Okay, so let's do one more. As a matter of fact, I'm going to have you do this one by yourself, so pause the video and answer this question. Okay, so let's see how you did. Okay, the first thing we want to look at is this number that's with our letter. Is it negative or positive? It's positive, so that tells me that my inequality is not going to flip in the end. Okay, but we still solve this one the same way. We're going to move the 5 over to be on the other side. So x divided by 3 plus 5 plus negative 5 is less than or equal to 9 plus negative 5. So we end up with x over 3 is less than or equal to, and 9 plus negative 5 gives me 4. Now how do I get rid of a multiply by 3? A divide by 3. I do a multiply by 3. Now I end up with x is less than or equal to 12. Okay, so this one, to graph it, I would put a 12, I'd put a closed circle on 12, and I would shade to the left because I need values that are less than 12. So again, one of the values that's in this solution set is 0 that I can check with. So 0 divided by 3 is 0, plus 5 is 5. Is that less than or equal to 9? And it is. Okay, so the one thing that we've got to remember when we're solving inequalities, okay, is that for inequalities, we solve them exactly the same way we do equations. We just have one thing to remember, is that if your coefficient is negative, then we're going to flip the inequality to find the solution set. So until next time.